RL, transient circuits. So RL, this is the second part of this chapter, and we mean by RL, there is inductor. In the RC circuits that we learned previous lectures, that was based on combination of resistors and one capacitor. Now here we will have a combination of resistors and one inductor. Only one storage element, then we can only use first order differential equations, so we don't want to go in higher order differential equations and make it more complicated. There is a duality principle between all resistors and inductors. So inductor and capacitor. They are almost opposite of each other. When we solve for the capacitor, we used to say Vc of t. While when we will solve for the inductor, we will say IL of t. So the overall formula, we will solve for the currents, not for the voltage, which is the opposite thing that we discussed in the capacitor. Also in the capacitor, in order to find the current, we used to say IC equals C dV by dt. While for the inductor is the opposite. We will say VL equal L di L by dt. So replace every current by voltage, every voltage by currents. Replace every inductor by capacitor, every capacitor by inductor. So they are the opposite of each other. And the other thing, which is when we calculate for tau, we used to say here R Thevenin's times C, while here tau will be L over R Thevenin's. That's other difference. Then when we do the steady states, the capacitor, we used to say it is open circuits at steady states, while the inductor will be short circuit at steady states. That's the differences. So if you understand RC very well, and if you understand the duality principle between them, then you can solve inductor easily. Okay? Now, let's go to the equation. Again, we said for the inductor, we will solve for the current, not for the voltage. So the current IL of t will be IL of infinity minus IL of infinity minus IL of 0, e power negative t over tau. The same thing as in RC, but the difference is replace the currents by voltage. Okay? This is only for the currents, for the inductor. This is the general solution. By looking at the general solution, we have three unknowns. What are these unknowns? Those are IL of infinity, IL of 0, and tau. So we need to have three parts or three circuits, different circuits to solve for everyone. Again, the same concept as in RC. Three unknowns, three different circuits. Now three unknowns, three different circuits. The same concepts. Keep in mind the difference is we are solving for the currents, and also whenever we deal with the inductor, we will make it short circuit. So let's start with this step number 1. Draw a DC circuit for t less than 0. For t less than 0, we are at steady states. Therefore, the inductor is shorts. Steady states makes the inductor shorts. Switch at initial position. Then solve for the inductor currents. Previously, for RC circuit, we used to solve for capacitor voltage. The capacitor was open circuit. Now it's different. It is short circuit and solve for the currents. Second step, which is very similar to the RC circuits, change the switch status, which is at the final status. Turn off all of the sources. By any voltage source will be short, any current source will be open. Then calculate R Thevenin's at the inductor terminals. So we just calculate R Thevenin's. The same thing we did in RC, exactly the same. But the difference is tau will be L over R Thevenin's. That's the thing. It's no longer RC. It's not RC. Now it's L over R. Okay? So in currents, opposites of the voltage. Inductor, opposites of the capacitor. Series, opposite of the parallel. Okay? Then here, we will calculate tau with this step number 2 to calculate tau. Step number 1, which is for IL of 0. Then step number 3, draw for t equal infinity, which is or at equal 5 tau. Here we are guaranteed that at steady state, after a long time of changing the switch status, So here we are at steady state. Therefore, at steady states, as we know in DC steady states, the inductor is short circuits. Apply the initial new switch status, then calculate the inductor currents. And that's it. So almost the same procedure with slight differences. Okay, are these procedures clear? It is very important just to understand the differences. While if you know how to do RC, and I assume everyone knows, we just finished the first exam, then the RL, it's just like slight differences. While the overall concept, it's the same. Here is an example. Now we need to solve for I of t. Look at where is I of t here, which is the inductor currents, and we can add V of t as well, such that V of t equal L di by dt. Okay, so how to solve for I of t, how to solve for V of t? Some people say, okay, we can say V of t equals V of infinity minus V of infinity minus V of 0 e power negative t over tau. Now, is this correct? No. This is only correct for the capacitor, so this is not right. Okay, how can I calculate the voltage? Do the current first, which is I of t equals I of infinity minus I of infinity minus I of 0 e power negative t over tau. That's the first thing. After that, in order to calculate the voltage, it will be L di of t by dt. That's what we'll see. Okay? And that's most likely what you'll see in the quiz. So you need to calculate for both the current and the voltage. Don't say this. This is wrong. It depends. Are you dealing with inductor or capacitor? We're dealing with inductors. Then that's the formula that's associated with it. Now, how to calculate the currents? By looking at the circuit, the first thing, there is a switch, then it is transient. So it's not DC. We cannot say the inductor is short circuit and do it. So let's do the transient problem. And there is, in Henry, the inductor is in Henry, therefore it is RL circuit. Then we apply this formula. So we realize that there are three unknowns. What are these three unknowns? Those are I of 0, I of infinity, and tau. So we need to solve three different circuits to find these three unknowns. Okay? Let's apply the procedure like step number 1. When I less than 0, which is at initial switch position, by looking at this switch, initially it's closed, then it will open at t equals 0. Is this correct? Initially it's closed. Then let me plot, or let me redraw the circuits. So we see here, this is the source, which is 140 volts. Then here is 4 ohms resistor, switch initially closed. Here is the 10 ohms resistor. Then 15 ohms resistor. After that, what do we have? The inductor is short circuits. Okay? And our target is to calculate the current of the inductor, IL of 0. How to calculate IL of 0? Now we need to calculate the current. It's DC problem. How to calculate the current of the 15 ohms branch? Any thoughts? Do you know how to calculate the current? What do you think?
You do KVL and KCL till we get there.
Okay, we can do KVL. So if we do KVL, we can label the nodes and the current. So plus minus V1, plus minus V2, plus minus V3. Here is I source, I1, and I2, which is the same as IL of 0. But we don't know all of the currents. We don't know IS, I1, I2. We don't know V1, V2, V3. Okay. So even doing KCL, KVL, they are not a good idea. Because we have multiple unknowns. Okay, any thoughts? We can find equivalent resistance.
That's right.
with the source, with respect to the source, to find I source. Is this correct? So let's do equivalent resistance. By doing equivalent resistance, here is 140 volts. We don't need to find for everything equivalent resistance for everything. We can say the 15 ohms, 10 ohms, are those series or parallel? Parallel. So this yields here to be 15 parallel with 10, which is 15 times 10 over 15 plus 10, so the answer will be 6 ohms. Now, as we know, in parallel, they are sharing the same voltage. So I will say like VP. Then we will say V2, which is the same as VP, V3 equal the same as VP. So VP equals V2 equals V3 because they are in parallel. Okay, do you agree with me on this? Okay, what else? We can calculate VP by using Ohm's law, which is I times R equivalents. They're R equivalents. Or not R equivalent, I will say like RP, which is I times 6. But we don't know I source yet. How to calculate I source? We can say that to calculate I source, since it's single loop, I source equals V source over the sum of the resistors, which is 140 over 4 plus 6, which is 10. 140 over 10 will be 14 amperes. So VP equal to 14 times 6, so the answer will be 84 volts. Is this clear? Now VP, which is 84, that's one way to calculate VP, or you can do KVLs to do that. I mean, I'm just doing one way. However, there are multiple ways to do it. So you can do it in different way. After calculating VP, you can do KVL to find V1. Then you can do KVL to find V2 and V3, and so on. So there are multiple ways. So after calculating VP, which is the same as V2 and V3, we can calculate IL using Ohm's law. How? Look at the voltage at the 15 ohms is VP, which is as we know 84. Then we know the resistance 15, so we can calculate the current. Ohm's law, right? V equal I times R. Therefore, I will be V over R, and that's what we will do. So Ohm's law, we can say I L of 0, which is the same as I2, equal to V2 over R2. So V2 84 over R2 15. So the answer will be 5.6 ohms, amperes. This is for the IL of 0. Then don't forget to box this answer. 5.6 amperes. So the first one done. The first unknown done. Okay? Any question about step number 1? Yes.
Does that say IL of 0 equals I2?
Yes, because here I2, IL of 0. Okay, let me give you a few seconds to write, then we will go to step number 2, which is to find R Thevens. Okay, let's go to step number 2 to calculate R Thevens and tau. So we will, first thing, let's redraw the circuits, apply the final switch status, and make the inductor, or find R Thevens across the inductor terminals. So we have, by looking at this circuit, we have 140 volts. This will be short circuits. Switch final status will be open. We need to calculate R Thevens across the inductor terminals. So let's do it step by step. The 140 volts is short circuits. Then we have the 4 ohms resistor. After that, the final switch status is open. Here is the 10 ohms resistor. Then here is the 15 ohms resistor. Then we need to calculate R Thevens across the inductor terminals. So basically, I will say this is point A, this is point B. So we need to calculate R Thevens. How to calculate R Thevens, which is R equivalent, basically, we can do it by labeling the nodes. Here is node A. This is node B. Or this is a node. And this is a node. Okay, so what do you think? Do you think 15 and 4 are those series or parallel? Series, but we have this branch. Do you think this can affect? Oh, not series. Okay. So we have this branch. Do you think this can affect? No, because they're assuming there is a current flowing from A and back to B. It will not be affected here. So don't worry about this one. So 15 and 4, those are in series. Because assuming a current, again, from A to B, they will be sharing the same currents. Now, how about the 10 ohms? Do you think this will be counted? No, this will not be counted. Why? Again, let me flow from A to B. I'm flowing from A to B. Then, is there any way to flow from A to B by going through the 10 ohms resistor? No, here we cannot go because it's open path. Let me use from B. Can I go from here to back to A? No, there is no way. There is no way to go from A to B using the 10 ohms resistor. Therefore, it will be this. Then the other thing, which is the remaining thing that we have, 15 and 4 are in series. So this will be 15 plus 4. So R Thevens will be 19 ohms. Okay? The next step, we are not done yet because we need to calculate tau. This is the second unknown, which is L over R Thevens. L is given in the question as 9.5 Henry over 19 ohms. So the answer will be 1/2, or in other words, 0.5 seconds. So this is tau, then box your final answer for tau. Okay? So finding tau can be, or R Thevens, easy at the same time tricky. You need to just be careful, like to understand what's going on. Step number 3, after a long time when t equal 5 tau, or in other words, t equal infinity. So we will use this to calculate IL of infinity. So what's the difference between this one and step number 1? It's very similar to step number 1, but the difference is apply the final switch state, the final switch state. So let's look at the switch. Here is the switch. The final switch status will be open. So I'm going to draw the circuits, which is something similar to this, but the switch will be open. So I'm going to make here the source 140 volts, 4 ohms, switch is open, 10 ohms, 15 ohms. The inductor is short circuit. Then that's it. And our target is to calculate the current of the inductor. Now, by looking at this circuit, look at the 10 ohms resistor. Let's assume there are some currents. So I'm going to assume a source current here. Do you think a current will be splitted here? We'll go current here. I1, and I'm going to call this as I2. What do you think about I1? Do you think it will flow? No, because it's open path, so it will be 0. Therefore, the current here as well equal to 0. According to Ohm's law, V equal I times R. So it will be 0 times R. Therefore, the voltage is 0 as well, right? Then in this element, since v equals 0, I equals 0, neglect this resistor or erase it. So it will be erased. We know this before. Whenever there is both voltage and the current are zeros, when both of them are zeros, remove it like it's not exist. Okay? So what I'm going to do, I'm going to redraw the circuits. 140 volts, 4 ohms, 15 ohms, and just erase it like it's not exists. Here is IL of infinity. Okay? Now how to find IL of infinity? I think now it's much easier, right? It is single loop. How to find the current for a single loop? So
I equals VS over some of the R's.
exactly. I equal V source over the sum of the resistors, which is 140 over 4 plus 15. So the answer will be 7.37 amperes. Okay? Now, don't forget to box your answer, 7.37 amperes. So it looks like, okay, we are done with the problem. Yes, we are done, but not, we still have some more steps to do. So basically, if there's 25 points for this problem, now I'm done with 15 points. I still have 10 points left. Okay, where are these 10 points go? Which is the first thing to substitute this in the formula to calculate the first 5 points, or the next 5 points. We will say IL of t equals IL of infinity minus IL of infinity minus IL of 0 e power negative t over tau. Then you need to substitute the numbers. That's why I say even during the test, if you don't know an answer of any step, assume any value, then keep going. If, for example, you cannot figure out how to find IL of infinity, assume, for example, 5 amperes, then you will lose only the 5 points associated with the IL of infinity and keep going with the answer. Okay? So here I'm just giving you some tips so you can find what's called, you can try to get more points. Okay, then let's substitute the values. 7.37 minus 7.37 minus IL of 0 was 5.6 e power negative t over 0.5. Then we can simplify it more. It will be 7.37 minus 1.77 e power negative 2t amperes. This is IL of t. So this is the next 5 points. Then there is still another 5 points, which is to calculate the voltage. Okay, how can I do it? As we know, the voltage V equal L di by dt, which is 9.5 d by dt of this expression, which is 7.37 minus 1.77 e power negative 2t. Then, how to find the derivative? It will be 9.5 times negative 1.77 times the exponential negative 2 e power negative 2t volts. So the final answer must be positive, but I don't have exactly what it is, what's the exact value, but V of t should be positive of 9.5 times 2, which is 19, 1.77 times 19, e power negative 2t volts. But you need also to use the calculator to find it. Okay? This is the other 5 points. So you can look at this question, calculating IL of t, VC of t, or I'm sorry, IL of t, VL of t. There are 10 points out of 25 points question. So let's assume in this question, if for example you were running out of time and you don't know what to do, you can assume some values. Assume tau is this value, IL is this value, infinity, IL of 0 is this value. Then substitute them in these expressions. You will get 5 points. Substitute them in for VL of t. you will get 5 points. So you will get 10 out of 25 for just spending 2 minutes on it. I mean, that's the worst scenario that I assume, other than leaving an empty question. Okay? Let's go to the next example. Solve for I of t when t larger than 0. Okay, when t larger than 0, it is inductor here. There is inductor, there is switch, there is inductor, so it's RL circuits. Then the initial switch status is closed, then it will be open. So let's start step by step. So in order to calculate IL of t, and we can say also V of t, IL of t equals IL of infinity minus IL of infinity minus IL of 0 e power negative t over tau, while I'm going to write, if you need to calculate VL of t, equals L di by dt. So we have 3 unknowns, then we need to do 3 steps. Step number 1, when t less than 0. When t less than 0, let's plot or redraw the circuit, 12 volts. The initial switch status is closed. Here are 2 ohms minus plus 12 volts. So here is 4 ohms. The inductor is short circuits. 2 ohms. Okay? And our target is to calculate the current of the inductor here, IL of 0. So this is the circuit that we need to do some calculations. It's DC circuit. Okay, by looking at this one, there is some simplification that we can do and will make the problem much easier. What's this simplification? Look at the 4 ohms resistor. Let me label the nodes around it. This is a node, this is a node, this is a node, this is a node. So 4 ohms, it's the same node at both ends. This means it is what? Short circuits. So this one can be cancelled because it's short circuits. SC means short circuit. So the next step, in order to simplify the question, I encourage you to redraw the circuit after erasing the 4 ohms resistor because it's short circuit. Here is 12 volts. 2 ohms minus plus 12 volts. Two ohms, and this is IL of 0. Now, how to calculate IL of 0? So the problem is moved to be like this way, and it is make it much easier. How to do it? How to calculate IL of 0? Any thoughts? KVL, KCL, Ohm's law? Well, look at this problem. We need to calculate the current associated with the 2 ohms resistor. If we know the voltage, we can find the current, right? So, how to calculate V2?
The outside loop.
Okay, we can do KVL at the outside loop, but we don't know the 2 ohms current, right? We don't know this voltage, right? So there will be some struggling. But there is a way that makes it much easier. Look at the outer loop. Look at the outer loop. If we do at the outer loop, if we do this loop, I can make it loop 1, loop 2, or we have outer loop, loop 3. Okay. So if we do KVL at loop 2, we don't know V1, we don't know V2. We have 2 unknowns, right? So it's not a good idea, loop 2. Look far away such that there's only 1 unknown. If we do KVL loop 1, we can calculate V1. That's good. Then after that, we can do KVL loop 2 to calculate this, right? So we can find the answer using this way. Do KVL loop 1, so we will find V1, then KVL loop 2 to find V2. But actually, this method takes, my point of view, might take longer time. There is an easier one, easier way. Then we can do it by doing KVL loop 3 or the outer loop. KVL, the outer loop, we have 12 volts, we have V2. The only unknown is V2. Is this good? Is this clear? Then we can do KVL loop 3, and that's it. So I'm going to write there are different options, like number 1, we can do KVL at loop 1 first, then KVL loop 2, or option 2, we can do KVL loop 3, or we can make it also in much easier way. So you see, like solving this circuit, maybe they have 3 different methods. Actually, the third method, or will make it much easier. Here. Look at this node and this node. Look at 2 ohms and 12 volts. Are those in series, parallel, or no relationship? Those are in parallel. Is this correct? Since they are in parallel, this means carrying the same voltage. So we will say, or V2 equals to V source 1, or which is 12 volts. Direct, because in parallel. That's the shortcut, which is avoid spending too much time in doing KVL1, KVL2, or doing outer loop KVL, then we can do it in parallel. So how to find the answer in shorter time. All of these 3 methods are correct. Use whatever more convenient for you, but here I'm just telling you the way that's how we are thinking, how we can think. So there are, again, multiple ways to solve it. So let me use the parallel. So V2 equals 12 volts. Therefore, we will say IL of 0 using Ohm's law will be V2 over R2, which is 12 over 2. So the answer will be 6. Then the first unknown IL of 0 is 6 amperes. Done. Okay? Now I'm done with step number 1 when t less than 0. Step number 2, to calculate tau. How can I calculate tau? By apply the new switch status and make every voltage source short circuit, every current source open circuit, find R Thevenins across the inductor terminals. So it can be clear by redrawing the circuits. Make sure everyone writes here, then we will start. Okay, let's go step number 2. To calculate tau and R Thevenins. So the 12 volts voltage source is short circuit. Then the switch status now, final switch status is open. Here is the 2 ohms resistor. Then the other 12 volts resistor is short circuits, because any voltage source will be short circuits. Final switch status. Here is 4 ohms resistor remains, 2 ohms resistor remains. Then the inductor terminals. Here is where we need to calculate R Thevenins. So how to calculate R Thevenins in this circuit? By looking at this circuit, we can see this branch, there is no need for it, right? It's open and there is no element on it. So in order to simplify, to make it easier for me or for us as well, I'm going to redraw it and just put the most important thing. Now, can you calculate R equivalent here for this circuit? Do you know how to calculate R? Yes. What's the equivalent circuit? If you're unsure, label the nodes. So the 2 ohms and 2 ohms, are those series or parallel? Series. Then their equivalent, is it going to be parallel or series with 4 ohms?
No.
Parallel. So we will say R Thevenins equals to 2 plus 2, because in series, then their equivalent will be in parallel with 4, which will make it 4 parallel with 4, which is 4 times 4 over 4 plus 4, or in other words, 4 over 2, so it will be 2 ohms. After that, to calculate tau, it will be L over R Thevenin. L given in the question as 1/3, 1 over 3, divided by 2, so the answer tau will be 1 over 6 seconds. Then don't forget to box your answer. This is step number 2. Then there's still, I need to calculate step number 3, which is when t equal infinity, or in other words 5 tau. So we will substitute, or we will redraw the circuits, but apply the final switch status. So what I'm going to do now, I'm going to redraw the circuit, which is very, very similar to step number 1, but I'm going to apply it with the difference. Apply the final switch status. So here is the 12 volts. So this switch is open. Here is the 2 ohms resistor. Minus plus 12 volts. Then here is 4 ohms resistor, 2 ohms resistor. The inductor is short circuits, so like this, to calculate IL of infinity. So look at the 4 ohms resistor. It is short circuit as well, right? Because the same node at both ends. So this one is short circuit. The other thing, the 12 volts, it is disconnected from the circuit. So I don't need it, right? No need for this, disconnected. No need. It is out of circuit. When you disconnect the power supply or disconnect the source, then you're not care about what's going on, right? So I'm going to redraw the circuit by removing the 4 ohms resistor and remove the 12 volts, whereas there is no need for it. So the circuit will be, here is the 2 ohms, here is minus plus 12 volts, 2 ohms, then here is IL of infinity. Okay? So is this clear how we moved from this circuit to this one? Any question? How to calculate the currents for the new circuits? What do you think?
I equals ES inverse of the hours.
I equal, because it's single loop. Since it's single loop, I source will be V source over the sum of the resistors, which is 12 over 2 plus 2, 12 over 4, which will make it 3 amperes. Now there is a trick that you need to be careful. Every time, whenever we have a source, we used to assume the current going out from the source, right? Is this correct? The current going out from the source. Let me make it more clear. If the polarity of the source goes down, then we will assume the currents goes down, right? Now, since the polarity is like this, then the current direction going like this way, right? It's traveling counterclockwise. However, IL is clockwise. So IL is the opposite of the reality. So what's the relationship between IL and IS? Negative, because they are the opposite direction. Therefore, this is the trick in this question, which is it will be negative IS, which will be negative 3 amperes, then box this. Or you can just box this. Then, now, I'm almost done. The final stages, which is label or substitute this in the equation. So I'm going to write it as IL of t equals IL of infinity minus IL of infinity minus IL of 0 e power negative t over tau. So IL of infinity, which is negative 3, minus negative 3, minus IL of 0, it was 6, e power negative t, tau, which is 1 over 6. So after simplification, it will be negative 3 minus 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 9, then there's a negative sign, we'll make it positive. So plus 9, e power negative 1 over 6 will make it 6, so negative 6t amperes. This is IL of t. Then box your answer. The last thing, which is to calculate VL of t. VL of t, which is L di by dt. L here is given as 1/3, so it will be 1 over 3 the time derivative of negative 3 plus 9 e power negative 6t. So it will be as 1/3 times 9 times negative 6 e power negative 6t. So, I didn't have any space, so I can write it here as VL of t will be negative, then 6 divided by 3, 2 times 9, 18, e power negative 6t volts, and t will be in the exponential. Then box your answer. So therefore we can say problem done. Okay? Is this clear? Okay, let me give you a few seconds to write, then I'm going to write some textbook problems about RC and RL. So you don't need to worry about RC for the quiz, but just look at the problems for RL. So textbook problems. Sorry, I didn't have space. That's why I wrote it in this corner. Which is 4.16, 4.18, 4.36. For the quiz, use only the problem for inductor. So the quiz, you will see only RL circuit.
You will not see RC.
Okay?